In this section, we'll explore crucial TypeScript essentials which you must know for this course and in general when working with TypeScript. Now, of course, this course does not replace an entire TypeScript course. And I do have a standalone separate TypeScript course if you want to learn more about TypeScript. But in this section, we'll explore how you can install and use TypeScript, how you can work with type annotations and what type inference is, and most importantly, we'll take a look at some basic and also slightly more advanced types and features which you'll use all the time when working with TypeScript in general, but also, important for this course, when using TypeScript in conjunction with React. In the next section thereafter, we'll then build up on this foundation and we'll get started with our first React and TypeScript app there. But let's start by creating a solid foundation in this section first. So let's get started with TypeScript, with this TypeScript refresher, before we then, thereafter, are going to combine TypeScript with React. Now, for that, to get started and also to use TypeScript with React later, we'll need to install it on our system. Because TypeScript is essentially an extension to JavaScript, but it's an extension of JavaScript that's not working in the browser, for example. Therefore, you always need to compile your TypeScript code to JavaScript code before it can run in the browser. So during development, we want to write TypeScript code, but then for production, we need JavaScript code. And therefore, we need to install TypeScript, or to be precise, we need to install the TypeScript compiler, which performs this compilation. Now, you can install it on a per project basis, as you learn if you pick that npm installation option on the official website. There you learn that you can add it to a specific project so that the compiler is in the end only available there. And that is the approach we'll use later once we use TypeScript in a React project. But you can also install TypeScript globally on your system or invoke the TypeScript compiler anywhere on your system without explicitly installing it first by using this npx command, which also needs npm to be available on your system in order to work though. Therefore, in order to install and actually also use TypeScript later, you must have Node.js installed on your system, even though we're not really going to write a Node.js code in this course. So you should visit nodejs.org, and then from there, download the LTS or the current version, one of the two. Once you did download that and you did walk through that installer that download gives you, you'll be ready to install TypeScript or globally invoke the compiler with help of this command here. And therefore, you can, for example, switch to your terminal and install TypeScript globally by running npm install -g TypeScript, or as mentioned, simply invoke it globally by running this command. And this will then compile any TypeScript file you're targeting to JavaScript. So therefore, now that we know how we can invoke the TypeScript compiler on our system, it's time to get started with TypeScript. For that, I'm in a brand new project opened here in Visual Studio Code, the IDE I'm using in this course. And in this basically empty project, I'll add a new file. First-app.ts. The file name, of course, is up to you, but it must end with .ts to signal to the IDE that this file will contain TypeScript code, because Visual Studio Code And actually, most modern web development IDEs have great TypeScript support built in, and therefore, as you will see, we'll get many TypeScript errors and hints without even invoking that TypeScript compiler. Instead, the IDE will help us when writing TypeScript code, but for that, it needs to know that we are writing TypeScript code and we are telling the IDE with help of that extension. And now in here, we can write regular JavaScript code, like this. This is valid, standard JavaScript code, and it works inside of a TypeScript file as well. Because that's really important, a really important takeaway. When working with TypeScript, you in the end still write JavaScript code. You still use all these JavaScript features you know. And later, once we switch to React with TypeScript, you will see that you write React code as you know it. But when working in a .ts file, when using TypeScript, therefore, you also got some extra features available. For example, if I now set username to 34, which doesn't make a lot of sense, I guess, I'm also getting an error here in the IDE. That's that built-in TypeScript support I already mentioned. If I hover over this error, I see that the type number, which I'm trying to assign to this variable, is not assignable because that variable seems to be of type string. And we would not get this error if this would be a JavaScript file. If I change the extension here, you see that the error goes away, because that here is valid JavaScript code. But it's not valid TypeScript code because the idea behind TypeScript is that types are enforced and that we get strict type checking, which basically means that TypeScript wants to help us avoid type-related errors. And this here would be such a type-related error. We initially store a string value in username, and then we suddenly store a number. That's probably not what we want, and that's why we're getting this error. Now, the error goes away if I don't assign an initial value, though. Because if I don't assign an initial value, TypeScript is not able to infer which type of value should eventually be stored in that variable. And you can see which type TypeScript is inferring for a variable by hovering over that variable. Here you see that it's the any type that's being inferred, because it's always this part after the colon that describes the type of a variable in this case. Now, previously, if I go back, when I assigned that string here, the text max, that inferred value instead was a string value. That was the inferred value here. But without that initial value being set, TypeScript is not able to infer a value, and therefore it does allow that number here, but it actually then also allows a string thereafter because it essentially now has no idea regarding the type that should be stored here, and therefore for this variable, it now falls back to the default JavaScript behavior, which is to allow all types to be stored here, because that's how JavaScript works. Now, therefore, in situations like this, where you are working with a variable that doesn't have an initial value, you as a developer might want to explicitly assign a type when you declare that variable. So here in this line 1. And you can do that by adding a colon after the variable name. And that's now not standard JavaScript syntax. Instead, that's now TypeScript specific syntax, adding such a colon after a variable name, because it's that colon that now separates the variable name from the type you want to assign to that variable. For example, here we could then enter string as a type, because that's one of the built-in types TypeScript supports, and I'll show you more built-in types in just a second. And with that, we're now overriding that inferred any type that we had before, and we're explicitly telling TypeScript that the type of username must be string. And therefore now we're getting an error when we try to store a number, because of course the type number is not a string. So that would be an explicit type assignment, and it makes sense in cases where TypeScript can't infer the type you want it to infer and where you still want strict type checking, which you typically always want when using TypeScript, because why would you use TypeScript if you would not care about types? It's literally its main feature. Now you can also mix this explicit type assignment here with a value assignment like this. But in cases like this, assigning a type explicitly as we're doing it here typically doesn't make a lot of sense, because TypeScript would be able to infer the type anyways. So you can still add this explicit assignment, but you typically wouldn't, because it doesn't make sense. You would only do that in more advanced scenarios where the inferred type maybe isn't the type you want, but here that's not the case. But now you know about the general idea of TypeScript and about type inference and explicit type assignments with that special colon syntax. And we saw TypeScript in action. Let's therefore now explore some important basic types and what we can do with TypeScript. Now, TypeScript ships with a bunch of built-in basic and also some more advanced types. Now, one basic type we already saw is the string type. Another type would of course be the number type. If I store a number in a variable, it's automatically inferred, and we could of course also explicitly set this to type number if we wanted to. So the number type is another crucial built-in type you can use. Of course, yet another pretty basic value type you use a lot in JavaScript is the Boolean type. So if I store true in here, this is inferred to be of type Boolean. So the true or false values are reflected by that Boolean type. So string, number are basically the most important built-in basic types that you will use all the time. So now that we learned about some basic types here, it's of course good that we have them and that we're able to write TypeScript code and that we can, for example, add those explicit type definitions. But how exactly do we get this TypeScript code into the browser or into our Node.js environment and execute it there? Well, for that we must compile it, as mentioned before. And as mentioned before, this can be done with help of that tsc command, which is available if you did install TypeScript globally on your system. Otherwise, you can use npx tsc to invoke it on demand without even installing it globally. You then simply add the file name that contains the TypeScript code you want to compile after this command, make sure that it's saved, and hit enter. And with that, TypeScript will go ahead, check this code for errors, and then convert it to regular JavaScript code that you could then execute in the browser or with Node.js. Which is why now I also have this JavaScript file here. And this file now contains almost the same code, but without the type annotation, for example. So without all these TypeScript-specific features. In addition, here you see that actually let was replaced with var, even though let is also a standard JavaScript keyword, but out of the box by default, TypeScript actually also converts the code such that it works in older browsers. This can be disabled and is something we'll take a look at in the next course section, but the most important takeaway is that you invoke the compiler by running this command and targeting a specific file, and that during this compilation process, all those TypeScript-specific features will be removed. Now, when writing TypeScript code, you will actually rarely run the compiler during development though, because the IDE already shows you all those important errors. For example, if I try to assign a number here, I'm already getting an error here in the IDE, which allows me to fix it. I could save this and try to compile it, and I would then get my compilation error here, where I also learn that I'm trying to assign an invalid type, but that's some extra unnecessary work. I can simply rely on my IDE instead. And therefore, here in this section, we're actually not going to use the compiler a lot. Instead, we're only going to work in that file and in that IDE and dive into all those important TypeScript features in theory before we then also see them in action in the next course section. And with that, let's continue now that we know about these basic types and we know how to work with them with help of the compiler. Now, sometimes in TypeScript, you have a variable that should not be limited to one value type. Let's say we have a user ID variable here. And the idea is that user ID can be ABC1, for example, but it should also be allowed to be 123. So it should be either a string or a number. Both should be allowed, and by default, when I write this code, that's not the case. You see I'm getting an error here because, of course, user ID is inferred to be of type string, because I assign a string initially. Now that's one scenario where you might want to explicitly set the type even though it is being inferred. But you might want to set it explicitly here because it's the wrong type that's being inferred. But what should the correct type be? Well, it should be a so-called union type, basically an alternative of multiple types. It should be either a string or a number in this case. And in TypeScript, you write this like that. You use this pipe symbol like an OR operator here, you could say. And with that, you're telling TypeScript that user ID is either of type string or of type number. And that's why now we're no longer getting an error down here, because we can now store a number in user ID. Now we can't store a Boolean value, for example. Here we still get an error because a Boolean is neither a string nor a number, which I guess makes sense. But being able to set a type to one of multiple types, so being able to give TypeScript alternatives, is another very important feature that you will use a lot, as you will also see throughout this course. So we don't just have these basic value types, we can also combine them. But TypeScript got more essential types built in, or support for essential types, I should say. Let's, for example, say that we don't just want to define all these user values as individual variables, but that we want to group them into an object. That would be a pretty common task. So we could create a new variable user, and then as a next step, we might want to store an object in that user variable, where we have a name property and an age property, and then maybe also a isAdmin property, which is true or false. And we could, of course, also add an ID, which is ABC, or which maybe should also be allowed to be a number. So we have that user object, and as you see, I can store it in this variable without getting an error, but that's only the case because I did not set an initial value here, and therefore user, as you learned, is of type any. So any value is allowed, and that's never a great type to have because it doesn't give us any extra type safety. So what we want to do here is we want to tell TypeScript that user should be an object. Now we could achieve this by explicitly setting user to type object like this. That's another type that's built in. With that, you see we're not getting an error here, and I would, on the other hand, get an error if I try to store a string, because that is not an object. It's a primitive value, a string value. That's why I would get an error here. But the object type isn't that great, because whilst it does now prevent us from storing a string in user, it does not give us any hints regarding the structure of the object that should be stored here. At the moment, I could store a user object like this in user, but I could also store an empty object without any key value pairs. And whilst that might sometimes be what you want, it's not what I want here. I want to make sure that user must always be an object with exactly that structure. So with a name key, which should hold a string, an age key, which should hold a number, an isAdmin key, which should hold a Boolean value, and an ID key, which should hold either a string or a number. And that can be achieved by not using this object type, but by instead defining an object type like this, by adding curly braces, opening and closing after that colon. Now we're still in the type assignment area here, so don't confuse this for the syntax for creating an object. We're not on the right side of an equal sign here as we are down here. Down here we are creating a value. Here we aren't, instead we're creating a type. And that difference is really important. Here we are setting the type for the user variable, and now we can set that object type just as we would create the value, but by defining the types for the different keys. So we could say that this object should have a name key, but now after the colon here, we define the type of the value that should eventually be stored under such a name key. So in this case here, string, because I plan on storing a string here in name. Then, since we are defining a type here, not a value, we add a semicolon, whereas in the value we use a comma. In the type definition, it's a semicolon, though a comma would work, but a semicolon is more common. And then we add the next key value pair, age, for example, which should be of type number. Then for isAdmin, I want to have a Boolean value. And then for the ID, I want to either allow a string or a number. So it's string or number, written like this, with that union type feature. And with that, we're now setting user to an object of that shape, which is why I can now store this user in that user variable. That works, as you see. But if I uncomment this code, I would get an error, because storing such an empty object, of course, is now not valid anymore because this object does not have this shape here. And that's how we get extra type safety when working with objects. So object types are another crucial built-in feature offered by TypeScript. Another very common type would be an array type. For that, let's say that we have a hobbies variable, which initially might be undefined, but which eventually should store an array of hobbies like sports, cooking, reading, something like this. Now at the moment, of course, this works because hobbies is of type any, but as mentioned before, that's typically not what we want. So we want to explicitly set a type here. But what should be the type? Well, we want to have an array in here. And indeed, TypeScript offers an array type, though it starts with an uppercase A, not array with a lowercase a. That's important. As you can see though, if I try to use it like this, I'm getting an error that a generic type array T requires one type argument. Now we'll get back to generic types later. In the end, what this means is that this array type only works if you give it more information about other related types, which makes more sense if you consider that such an array in the end, of course, is the combination of two values and therefore value types. It's an array, that's the main value, but it's an array of strings here. That's the related value. And that's therefore why this array type needs to be written like this, with these strange angle brackets that wrap the related type. So the type of values this array contains in this case here. So that's how we would say that hobbies should be an array of string values. And as a result, we, for example, are not able to store a bunch of numbers in there, because that's an array, but it's not an array of strings, of course. Now, that here is one way of writing it, but it's also a pretty long or complex way. Therefore, you'll also often see this shortcut. This is the same kind of type in the end. This means that hobbies should be an array of strings. And of course, you don't just have string arrays, you could also have number arrays or Boolean arrays, or also arrays of objects. For example, you could have a type like this, where you're saying that you want to have a bunch of objects of that structure in an array. And we will see such slightly more complex types later in the course and also in the React projects we're going to build. For this introduction, it's just important to understand that we do have types like this. And therefore, with this array type and this object type, as well as the union type feature and all these basic types, string, number, and Boolean, we got a solid TypeScript foundation on which we can now build up on to dive into more important TypeScript features, which we will need in order to use TypeScript with React later. So now that we explored these basic types and these core concepts, let's take a look at where in our code we can use such types. And of course, we already see one very common use case here, a variable. Assigning types to variables is extremely common. Now, by the way, of course, you can also assign types to constants. For example, if I had an API key constant here, we could do that, but since it's a constant, you of course typically don't set the type explicitly, because a constant always has an initial type from which the type can then be inferred. And this inferred type here, by the way, is even a bit stricter. It's not just any string, but it's exactly this string here, because a constant can't be reassigned anyways. That is the idea of a constant. You cannot reassign it. But variables and constants are one construct where you can use types, or where you do work with types. Another very important language feature where you'll use types are functions. We can use types in functions, for example, for the parameters. If we create an add function that should receive two parameters, we might want to add types to those parameters, like this, by adding a colon after the parameter name, so after A and B, and then by setting the type after that colon. That would, for example, enforce that this add function is called with two arguments where both arguments are of type number. And of course, we could mix and match those different types just as we needed. We can also accept more complex types here, like objects with fields inside of them. You can use all those types here, and you therefore can make your functions more type safe. Then here we can of course work with those values, and therefore, for example, here this result constant is inferred to be of type number because A and B are numbers. So TypeScript is really smart regarding that. And we could, for example, output that. What we can also do with functions and types is define a return type. So the type of the returned value. Now this add function, which I created here, doesn't actually return any value. So we could set the return type by adding a colon after this parameter list. That's how you set a return type, by setting it to undefined, which is another built-in type. This would say that this function yields undefined as a value, as a return value, because it doesn't return anything. But for this specific scenario, for function return types, we got a better type that you should use instead if you have a function without a return statement. And that's the void type. Another type built into TypeScript that's meant to be used in conjunction with functions. And to be precise there, it should be used as a return value type, as we're using it here, if you have a function that doesn't return anything. So instead of using undefined, which you could technically use, you should use void. And that's how you could set a return type. Now, if your function does return something, we would therefore get an error now, because we now are returning a number when we're saying that we're not returning anything. So if we are returning something, we want to set our return type to that. So in this case, to number. Though you can also omit that return type, since TypeScript is able to infer that we are returning result here, which is of type number, and therefore, if you hover over add, you see the function type definition here, you see the parameter types, and you see the inferred return type here. So that would also be possible to rely on type inference, but you can also explicitly set the return type if you want to. Typically, you wouldn't do that though. Now, when working with functions, it's important to understand and keep in mind that in JavaScript, functions are, of course, regular values. So if I create another function, calculate, that, for example, receives two numbers, and then a third argument that should be a calculation function that should be executed on these two numbers, I can do that. This is valid JavaScript code because in JavaScript you can use functions as values. So here the calculate function, which I defined, expects a third parameter which should be a callable function. Now, since functions are values in JavaScript, you of course also might want to set a type here, a function type. And we see such a function type here if I hover over add. This in the end is the type of this add function. That's how such a function type is defined in TypeScript. It's the combination of a parameter list and the return value type in the end. So if you have a place where you are working with a function as a value, you can also therefore define such a function type. Though the syntax for defining such a function type looks slightly different, you basically create an arrow function here, you could say, but keep in mind that we are in a place after this colon, after this parameter name, where we define a type and not a value. So this here is a type creation, not a value creation. Nonetheless, it looks like an arrow function because that is the TypeScript syntax for creating such a function type. And there you then have your parameter list, like this, for example. And then after the arrow here, your return type. And if I reformat that, that's a bit easier to read. And this would now say that calc function wants a function as a value, so a value of type function, and it shouldn't be any function. Instead, it should be a function with this signature, with this configuration, so to say. A function that gets two input parameters, which are both of type number, and which then returns a value of type number. And therefore, with that setup, we could call this calculate function by passing two numbers to it and a pointer to this add function. This add function, keep in mind, is a function with such a signature. It is a function that takes two parameters, which are both of type number, and which then returns a number. So it fits this type definition, which is why we can call calculate like this. So functions and types being used in conjunction with functions and function types are some important TypeScript features which you must know. But here, when we take a look at this code example, you also see one potential problem which you'll sometimes encounter when working with TypeScript. Your type definitions can get rather long, like this function type definition for the calcfn value here. Now, this is not a big problem here, but we might want to outsource this type definition, and you can do that in TypeScript. You can create custom types, you could say, so-called type aliases, by using the type keyword, which is not a standard JavaScript keyword, but instead a keyword made available by TypeScript. And this type keyword allows you to create a custom type, you could say, or to be more precise, to assign an alias to some other type. So a custom name to some other type. For example, here we could name our type addFn, and this name is entirely up to you. And then you add an equal sign, and now even though we have an equal sign here, since type is a keyword provided by TypeScript, which is there to allow us to create our own types, on the right side of this equal sign, we don't create a value with which we work in our code, but we instead create a type. For example, we can copy this type definition and use that here on the right side of the equal sign. And with that, we would store this type definition under that name, so to say. So that now down here, we can use this addFn type, this custom type. And we can, of course, also reuse that and use it in all the places where we're working with an object of that type. And this is therefore another super important TypeScript feature which you'll use a lot. Because you cannot just use it for function types, which tend to be rather long, but for any type. For example, also up here, where I had this user ID, which was a string or a number. We could also create a type alias here and name it string or num, for example, and then store this union type under that alias and use that alias name here in the place where we had the union type. And that's indeed another very common scenario for using this type keyword, that you're storing union types with a custom name. Another common scenario are object types. You can also use the type keyword here to, for example, create a user type and then store this object type definition under that name so that down here you can refer to your custom type. And this could then also, of course, be reused in all the places where you want to use that type. So that type keyword and this feature, which allows you to create custom types, or to be precise, assign aliases to other types, is a feature you'll also use a lot in TypeScript. So this type keyword and this feature here is an important one, as you learned, but when it comes to defining object types, that's just one option you have. Another option is to create a so-called interface with help of the interface keyword, which is also provided by TypeScript and which is also not built into JavaScript. Now you use this interface keyword by then adding any name of your choice after interface, for example, credentials, though this name here is up to you. Just like this custom type name here, it typically starts with an uppercase character though, even though that's not a hard rule, but it's a common pattern. And then the difference to the type keyword, or one difference, is that you don't define the type separated with an equal sign here, but instead you add curly braces after that name. Because the interface type is essentially for creating objects. I'm saying essentially because you can also define function types with it, but that's not too important here and not something you'll probably use a lot. And therefore, the most common use case for the interface keyword is to define object types. So you have the interface keyword, then your name, and then the curly braces, and then here you have your key value pairs, though again, not to create an object value here, but instead a type definition for an object. So any key name of your choice, but then the type of the value that should eventually be stored under that key. So for example, string here. And that could then be our credentials object. We can then use this credentials object like this, for example, and then set creds equal to an object where we now have to add password and email. And you'll also see that if you open the auto-completion, here I'm getting this suggestion for email and not for any other keys, because of course TypeScript and my code editor understands that creds is of that type and that in there we only have these two key value pairs. So we're getting great IDE support here, and we can then store our details here. So that's another way, another popular way for defining object types. And you now, of course, might wonder why you would use interface if you have type, and vice versa. So we can use both the type keyword and the interface keyword for defining object types. I had that user object type defined with the type keyword here, and we had this credentials object type here defined with the interface keyword. So when would you use which? Well, in general, you can always use the type keyword. And that also allows you to define other types than object types, as you're, for example, seeing here in line 53 in my case here with that example, with that function type that's being stored in a custom type with help of the type keyword. Interface is more limited when it comes to that because it's basically limited to object types. Nonetheless, the interface type also has some advantages. For example, if you're defining a class of credentials, for example, you can use the implements keyword to implement an interface. And this then forces you to add the properties and methods that are defined in the object of that interface in your class as well. So here I now have to add the email and password key value pairs to that class if I'm implementing this interface. And then I could also add additional properties to this class, but I have to at least implement these. So you can use interfaces as contracts, you could say, classes have to adhere to if you're implementing them. And you could then, for example, create a login function where you expect to get credentials of type credentials, so of your interface type. And login could then be called both with the creds object that I created earlier, so with that object that is of that interface type. But we could also call login with a new instance of credentials, since that also implements credentials, and therefore TypeScript knows that this will also be a valid object that has at least the properties and methods that are wanted by that interface. So this feature, where you can implement interfaces into classes, can be a reason for using interfaces over the type keyword if you are working on a project where you are using classes, which many JavaScript projects don't, but if you have one that does, interface might be a bit better. Another reason for using the interface keyword for defining an object type is that it's easily extendable. You can simply redefine the same interface with the same name without getting an error and add more properties or methods to it. Now you might wonder why I would do it like this and not just add it here, but that can be useful if you're, for example, creating a library which you're sharing with other developers from all over the world, and you have your interface definition in some part of your library, but you want to allow those developers to easily extend your interface. With that feature, which is called declaration merging, that's quite easy to do without any extra effort, because those developers can basically just redefine your interface with your name and add any properties or methods they need without any extra work. So that can be another reason for using the interface keyword. In basically all other scenarios, and therefore in the end in most use cases, it therefore doesn't matter if you use interface or type, and you can use whatever you prefer. Now, regarding types and interfaces and object types, there's one other important feature you should be aware of. Let's say we have a type admin, which is an object, where we maybe have a permissions property, which should be a string array. And then we maybe have another user type, or app user, since I'm already using the name user up there in my file here. So here I'll name it app user, where we maybe have a username. And now we maybe want to create a new type, app admin, which should be the combination of these two types. Now, of course, we could merge the types manually, but we might have a reason for keeping them separated. Because maybe somewhere else in the app we need just an admin or just an app user type. So we want to have these separate types, but we also want to create a merged type. Now, of course, we could now manually create such a merged type by copying all those different properties into a new type object. But that's unnecessarily cumbersome. After all, we already do have our type definitions here. Well, we could use a union type, but that would not give us the desired result. Now app_admin is not a merged object, but in the end just one of these two types. So it's allowing both types in a value of that type instead of merging the types. To merge the types, we need the AND operator instead. With that, app_admin is the combination of these two types. So if I'm creating a new admin variable, which is of type app_admin, and I then assign a value, that must be an object with both a permissions and a username property. And permissions is then an array, an empty array, or an array with strings, and username also must be a string. And that's how we can merge such user types. We can also merge types if we went for the interface keyword instead of the type keyword. So for that, I'll comment out that code so that we can still see it, but it's no longer active. And I'll copy this object type definition down here to define it as an interface, admin. Then I'll also add an interface app user, which has that username. And we could now create a new app admin interface, which extends admin. So it's this extends keyword that now makes sure that we take all the properties and methods that are defined in another interface, the admin interface in this case, and merge it into this new interface which we're creating here. And we can extend multiple interfaces here, separated by a comma. And then we could add any additional properties which we might need here, or we keep this empty. And with that, if I copy this code here from above, where I'm using this app admin interface, this code again works, but now using interfaces instead of the type keyword. As you can see, if I now remove one of these properties, I'm getting an error because username is missing despite being required by app_admin. So that's how you can merge multiple object types when using the interface keyword. So at this point, we of course covered a lot of important TypeScript concepts here, and we're almost done for this module, but we're not done entirely yet. Instead, there still are a few main features I still want to cover before we explore React in conjunction with TypeScript. Now, the first important feature are so-called literal types in TypeScript. And for that, let's say that we want to have a role variable which should be either admin or user or editor, but not any other value. Now, of course, for that, we could set role to be a string. And with that, we could store admin and user and of course also editor in there. But as you might already guess, we can also store any other string in there. And that's not really what I want. I don't want to accept any string in here, but one of these strings. Now for that, we can use this literal type feature I already mentioned. You can set a specific value, for example, a specific string as a type. So keep in mind, here we are in TypeScript land. After this colon, after the variable name, we are in TypeScript world. So here I'm not really creating a string value, but instead a specific string type that's limited to a specific string value though. At the moment to an empty string, which could be the value I want, but it isn't here. Instead here, we could use admin as a value. That forces role to be only that value, that specific string. Which is why now here we're not getting an error anymore, whereas for all the other string values we do. Now, of course, here I want to allow multiple values. And how can we do that? Well, by creating a union type, by accepting alternatives. So we can use the pipe symbol here to also allow the value user and also the value editor. You can also create number literal values. So now, for example, the number 1 and only that number would also be allowed. But here, it's really just these 3 strings which I want to allow. And therefore now here, if we try to store ABC, we're getting an error and all the other strings work just fine. And that's therefore another pretty important and common feature when writing applications with TypeScript. Now, when working with union types, no matter if you're using such literal types or more general types like just string or number, it is quite common that you sometimes have code that should only be executed if you have a value of one of the accepted types. For example, we could add a function, perform action, where action is maybe any action described by any string, but where we then want to get the role of the user that's currently logged in. And that should be either admin, user, or editor. So as a first step, so that I don't have to copy and paste that, which I could of course do, but which is unnecessary work and makes that function definition longer, to avoid that, I'll add a custom type, which I'll name role, which stores that union type, and which I can now use here and also here in my function definition. With that, I have a function that wants an action and a role which is either admin, user, or editor. But now here in perform action, we might want to check if role is admin, because only then we might want to execute that action. Therefore, we can add an if check here and check if role is equal to admin. And as you see, I'm getting great auto-completion by my IDE here, because it understands that role can only be admin, user, or editor due to the way this type is set up. And we can check if role is equal to admin, and if that's the case, I want to run my action, so do something here. And otherwise, I don't do anything. And this might seem obvious, but it is an important pattern, especially when working with union types, that you add if checks to your code to check if you have a certain value, and then you execute different code for different values. Now, if action would be either a string or a number, we could therefore, for example, also add another check, maybe nested in here as a separate if statement, or by adding a condition here. We could, for example, check if type of action is equal to string. Now, the type of operator is a default operator built into JavaScript. It's not coming from TypeScript. It can be used to get the, guess what, type of a parameter or variable. And as a result, you'll get a string that contains the built-in types, for example, string. And now we would only run this code if the role is admin and we got an action that is of type string, not a number. Otherwise, if we have a number or a different role, this code in the if statement would not execute. So having extra guards, type guards, you could say like this, in conjunction with union types is a common pattern, which you will also see from time to time in this course, and it is therefore a pattern I wanted to cover here.